Hello everyone, welcome to my channel IndiaGATE. This is Nandani Sharma and now we're going to explain the linear algebra related topics. And my first topic of the linear algebra is matrix. That means type of the matrices. So here I discuss 26 type of the matrices. So let's get started. So what is the matrix? So definition of the matrix is defined as an arrangement of m into n number of the form of m horizontal and n vertical lines is called the matrix type m into n and order n into n. For example, here 2, 2, 3, 1, 0, 2 it's 2 into 3 matrix, and it is represented like here A11, A12 till A1n, A21, A22, A2n times, and here at the last row of the matrix is represented by AM1, AM2 and with AM into n. That is an m into n matrices. Now come to the topic, that is type of the matrices. So here we explain and I explain 26 type of the matrices. So first matrix is the horizontal matrix. So what is the horizontal matrix? It is very simple. That says the number of column is more than the number of row, then it is called the horizontal matrix. So here the number of column is 4 and number of the row is 2. So it is an horizontal matrix. Now come to the next type of matrix, that is your vertical. So vertical, if a matrix number of row is more than the number of column, then it is called vertical matrix. It is inverted from the and inverse of the horizontal matrix, where for example here 1, 2, 4, 5 and 6, 8 is your vertical matrix, where m, that is your row, equal to 3 and n, that is your column, equal to 2. So here row is more than column, then hence it is called vertical matrix. Now next is a row matrix. A matrix having only one row is called a row matrix, and multiple column. So column having infinity but a row is one, then it is called the row matrix. And similarly here column matrix having only one column is called column matrix, and multiple row, that is called your column matrix. Now come to the next type of matrix, that is your square matrix. So a square matrix is represented and defined as the number of row is equal to number of column, means the number of row m is equal to number of column n, then it is called the square matrix. For example, here the number of row is 3 and number of column is also 3, so it is your square matrix. Now sixth type of the matrix is the null or zero matrix. If element of n into m matrix are 0, then it is called a null or zero matrix, and it is denoted by 0 m into n. Now come to the next type of the matrix is unit matrix. So unit matrix is defined as a square matrix having a unity for its element in the leading diagonal, and all the elements as 0 is called unit matrix. For example, here 1 0 0 0 1 0 0 0 1 is your unit matrix, and it is also defined by the square matrix. Okay, now next matrix is diagonal matrix. A square matrix in which all the elements except those in the main or leading diagonals are 0 is called as and known as the diagonal matrix. For example, here the matrix is given like this, and here diagonal elements is non-zero and other elements is 0, then it is called the diagonal matrix. Now come to the scalar matrix. A diagonal matrix in which all the matrix elements are equal to a scalar CR is called scalar matrix. So here giving the diagonal matrix having the equal to a scalar, so it is called a scalar matrix. Now come to the next matrix, that is your upper triangular matrix. So upper triangular matrix is defined as a square matrix in which all the elements below this principal, that is mean diagonal, are 0 is called the upper triangular matrix. For example, here the main diagonal is 1 3 1 and below the main diagonal elements are 0, so hence it is called the upper triangular matrix. Now come to the lower triangular matrix. It is the inverse of the upper triangular matrix, in which the all element above the main diagonal are 0. So here main diagonal is this and all the upper element is 0, so it is called the lower triangular matrix. Now come to the triangular matrix. So triangular matrix is either upper triangular matrix or lower triangular is called triangular matrix. Now 13th type of the matrix is singular and non-singular matrix. So a square matrix is said to be singular if its determinant is 0, is that mod A equal to 0, where is the square matrix, and non-singular if the determinant is non-zero, that is mod 0 or determinant is not equal to 0. Now the given example is a singular matrix. Why? Because the determinant of this given matrix is 0. Now come to the what is the transpose of the matrix. So for example, if the matrix is obtained by the changing the its row into the column and column into the rows, so it is called the transpose of A, and it is denoted by A dash or A to power of t. Now here A is represented like this, like 2 3 4 and 6 1 8, that is 2:3 matrix, and after the transposing of the A we got here 2 6 3 1 4 8, like 3:2 matrix. So 3:2 matrix is your transpose of the matrix. Now here notable point is that if the order of M is M into N, then the order of A transpose is N into M. Now come to the properties of the transpose. If A and B are the two matrices and A transpose and B transpose are their transpose, then double transpose of the any matrix is going to be itself, means the complement of the two or type of the complement of the matrix is equal to the A. Now B properties say if A plus B complement is equal to A complement plus B complement or transpose, we also say that if A dot B transpose, so it is equal to B transpose into A transpose. Now notable point is that here two matrices can be add and subtract if they have same order, means order must be same, then you have to add and subtract the matrices. Now come to the another notable points are here point P. A matrix addition is commutative, means A plus B is equal to B plus A, and C notable point is matrix addition is associative, means here using of the parenthesis firstly. So here A plus B in the parenthesis plus C is equal to A plus in the parenthesis B plus C. Now notable point D is here null matrix is additive in identity, means if we adding 0 matrix with A or null matrix with A, so it is represent itself, means A plus 0 is equal to 0 plus A is equal to A. Now E notable point is if A is a matrix, then minus A is additive inverse. Yes, is that A plus minus A is equal to 0, that is your null matrix. Yeah. Another point is that what is the matrix multiplication? So matrix multiplication, a product of two matrices, exists if the number of column of the first matrix is equal to number of rows in the second matrix. For example, here A m into n dot b n into m is equal to x m into m. Here properties of the matrix multiplication is defined as A. Multiplication is not commutative in general. Yes, it is right, because we can't be prove A into B is equal to B into A. Now second property is property B, that define the it is associative. Yes, it follow the associative rule. And C property defined if A and I are the square matrix same order, then A I is equal to I A is equal to A. Yes, because here I is equal to 1 as we suppose, so we get here A itself. Now come to the D property. So property D is defined as any positive integer n, then I to power of n is equal to I. Yes, because the 1 to the power of n is always 1, not be varying. So it is clearly. And here property E is defined as A to power of 0 is always I. Yes, we know that any number of any matrix power of 0, so it is always 1, that is identity matrix in this case of the matrix. Now next matrix is a symmetric matrix. So symmetric matrix is defined as a square matrix said to be symmetric if A transpose is equal to A. For example, A is equal to 1 3 5 minus 3 2 7 5 7 3, then it is called your symmetric matrix. So here given matrix A is your symmetric matrix. Now here notable point is that K is also symmetric if K is a scalar. Okay. Now next matrix is skew symmetric matrix. A square matrix is called skew symmetric if complement of the A means transpose of A is equal to minus A. For example, so here giving the matrix is like that, so it is your skew matrix. Now here notable point is that K is also a skew matrix if K is a scalar. Now next type of matrix is periodic type matrix. So periodic matrix is defined as a square matrix A is called the periodic if A to power of K plus 1 is equal to A, where K is the positive integer. If K is least positive for which A to power of K plus 1 equal to n, then A is said to be of period of A. Now next is your idempotent matrix. So idempotent matrix is defined as the A square is equal to A. If any matrix is follow this property, so it is called, that matrix is called idempotent matrix. Now next is your evolutionary matrix. So evolutionary matrix is defined as a square matrix A square is equal to I, where I is your identity matrix. Now come to the next type of matrix, that is your nilpotent matrix. A square matrix is called nilpotent matrix of the order m if a to power of m is 0 and a to power minus 1 equal to not 0. So it is called the nilpotent matrix, where the real matrix of A, where m is a positive integer and 0 is a null matrix. Now come to the next, that is your real matrix. So real matrix is defined as the A is equal to complex conjugate of the matrix, where A bar is represent your complex complement conjugate of the matrix. Now come to the next matrix, that is your imaginary matrix. So imaginary matrix is defined as the A is equal to minus complex conjugate of the matrix. So here A is equal to A bar. Okay. Now next is your what is the complex conjugate of matrix? So it is also type of matrix which complex element are replaced by its corresponding conjugate element number is called the complex conjugate of that matrix. It is denoted by A bar. Okay. Now come to the example for more understanding. So example are given as here, if A is equal to 1 plus I and 2 plus 3I, so the complex conjugate of the matrix is represented like the negation form of the matrix. So negation form of the I, that is imaginary. Okay, means if 1 plus I, then conjugate is 1 minus I. Okay, in this format. Okay, now next type of the matrix is Hermitian matrix. So what is the Hermitian matrix? A square matrix is said to be Hermitian matrix if conjugate complement is equal to or conjugate transpose is equal to A, means A theta is equal to A. Now 24th type of matrix is skew Hermitian matrix. A square matrix is said to be skew Hermitian if A bar of transpose equal to minus A or A theta is equal to minus A. Now next 25th type of matrix is orthogonal matrix. It is very most important type of the matrix because the mostly questions is related from this orthogonal matrix and properties also followed by the orthogonals. Okay, our square matrix A is called orthogonal if A into A transpose is equal to A transpose into A is equal to I. So it is called your orthogonal matrix. Now notable point is that if A and B are two orthogonal matrices, then AB is also orthogonal. Okay, now next point is here, and last type of the matrix is unitary matrix. So a unitary matrix, a square matrix A is said to be unitary if A into A theta is equal to A theta into A is equal to I. So it is called your unitary matrix, means a matrix multiplication with a Hermitian matrix is equal to identity matrix, then it is called your unitary matrix. Now this session is end here. I hope you understand all the type of the matrices. If you have any queries, so please comment me. Thank you for watching.